Hi there and welcome to tutorial 2, which is on algebraic fractions as part of the Edexcel Core 3 Maths A-Level course, but this work should be applicable to most other core maths modules. As always, for more help with your A-Level or GCSE maths, look at my YouTube channel or website. Now, we've already done cancelling algebraic fractions and generating equivalent algebraic fractions, and we looked at the Edexcel specification in lesson 1 or tutorial 1, and this is what we're attempting to do. Now we need to take this to the next level by being able to add, subtract, multiply and divide rational expressions and use the skills of factorising, cancelling and generating equivalent fractions when doing so. So let's start off tutorial 2 by looking at something quite straightforward, multiplying and then dividing algebraic fractions. So multiplying fractions. Before we look up here, let's just think about what we do with numbers. Well, you should remember that when you're multiplying fractions, you just multiply top by top and bottom times bottom. So we would get 2 times 1 over 3 times 7, which is simply 2 over 21. And here we do the same thing. So we would get 2 times 3 over 3 times 7, okay, which is 6 over 21, which we can actually simplify because 3 goes into top and bottom, and we could write that as 2 sevenths. Now, I want to just pause there a second. I could have done this a slightly better way. Remember, we know the answer is 2 sevenths. You know that when you multiply, all the factors on the numerator will end up on the top of the new fraction, and all the factors on the denominator end up on the bottom of the new fraction. So before you multiply, you could spot common factors. There's going to be a 3 on the top and a 3 on the bottom, which would cancel with each other, and you'd simply be left with 2 sevenths. Easier way of doing it, rather than multiplying the whole thing out and then cancelling. It saves you steps. It makes your multiplication easier, and it stops you having to cancel a step at least. Okay, what about this one? Part 3. Anything common here? Well, look, there's a 3 common on top and bottom. Okay, there would be a 3. 9 would be 3 times 3, and there's a 3 here, and one of those 3's would cancel. And there's a 2 on the top and bottom. Because 14 could be 2 times 7. So really what you've got is 2 over 3 multiplied by 3 times 3 over 2 times 7. And when you do some cross cancelling, you would just simply be left with the answer 3 sevenths. And it makes your life a whole lot easier. How do we translate that into algebraic expressions? Well, there's a step process I've labelled above. Essentially what you do is you factorise the top and the bottom of numerator and denominator of both parts. You cancel common factors that are in both numerator and denominator, and then you write up the answer to the remaining multiplication by doing top times top over bottom times bottom. Okay, let's have a go here. Any common factors, firstly? No, we can't factorise anything. A multiplied by C, a mathematician would write as AC. And B multiplied by D, a mathematician would write as BD. Nothing else we could do there. We're done. Okay, how about here? Now, before we launch into multiplying, let's see if there are any common factors. 3 and 5, nothing. X plus 2, x squared minus 4. Well, this should look familiar to us as a difference of 2 squares. It's x plus 2, x minus 2. Okay, so really there's an x plus 2 on the bottom here, which would cancel with that x plus 2. And we'd still have our 3 on top, we'd still have our 5 on the bottom, and we'd have our remaining x minus 2 on the bottom. That x plus 2 and that x plus 2 would have cancelled. And we're done. Much easier way than multiplying out, trying to factorise, etc. Now here, let's have a go at this one. Let's do a bit of factorising first. Step 1. Let's factorise this. Well, I'm going to write this whole one out actually. This would be 2x plus 4. Let's factorise the bottom. Well, that factorises into x plus 3, x plus 2. And we're multiplying the whole of this by this here. Now that factorises to simply x plus 3, and the bottom doesn't factorise, it's simply x plus 4. Okay, before we start multiplying across, any cancellation that could happen? Well, that x plus 4 could go with that x plus 4, they would cancel, and that x plus 3 would cancel with that x plus 3. Anything else? No, not really. So we're left with the answer. We've still got the 2 here. We've got this x, so 2x. What have we got left on bottom? We've got this x plus 2, and we're done. And that's how you multiply fractions. Quite straightforward. As always, factorising is the key thing. Factorise numerator and denominator. See if you can do any cancellation, and then multiply the thing out. Okay, time for you to have a go at a few yourself. Pause the video. In 10 seconds, I'll go through the answers to the following. Here we go. Okay, let's have a go through these. So let's factorise everything in sight really. The top here factorises to n plus 2. The bottom, if we factorise that, that should factorise to n plus 2, n plus 4. We're multiplying that by, well, an n plus 4 on the top, we can't factorise that. Put it in brackets just to remind us we're doing multiplication, and over, and n squared is n times n, isn't it? So now we cancel that n, cancel with that n plus 2, we cancel with that n plus 2, that n plus 4 cancels with that n plus 4. We're not left with 0 on top, we're left with a 1, and we've got an n on the bottom. So the answer is 1 over n. Here, factorise the top, well, we've got a 3 multiplied by x multiplied by x. I'm going to write it like that. On the bottom, we could factorise that a 9, and we'd have x subtract 1. And we're multiplying this all, well, we could factorise here, we could factorise out a 4, and we'd have x subtract 1, all divided by, and 2 times x. 2 times x. Okay, what could we cancel here? Let's use a different colour pen. 1x with that 1x. We could also cancel the x minus 1 with that x minus 1. And we've got 4 over 2 here, which we know is 2. 4 over 2 is 2. So this whole thing here, oh, and we've got a 3 over 9 here. We could cancel that down. That 3 would just be a 1, and you'd get a 3 on the bottom. So we'd have x. We said this cancelled to a 2, so we'd have 2x over 3. So our answer for this would be 2x over 3. Okay, last one here, have a go at this one together. Factorise out of 4, we get x subtract 3. On the bottom here, it's a difference of 2 squares, so it would be x plus 2, x subtract 2. And we're multiplying all of this, well, this factorises to x plus 2. And this bottom here factorises to x subtract 3, x plus 1. See why you have to be very good at your factorising. Now let's just see what we can cancel. Well, an x plus 2 goes with that x plus 2, an x minus 3 goes with that x minus 3, and we'd be left with 4x on top, and we'd be left with x minus 2, x plus 1 on the bottom. And we're done. So hopefully you got those answers yourself, and if not, work through your mistakes and can now get them. Okay, now let's move on to dividing fractions, which is very similar. Now, without looking up here at the green, when we're dividing fractions, you should remember from your numeracy work that what you end up doing when you divide fractions is you keep the first fraction as it is, you change the divide to a multiply, and you flip the fraction. So you convert it to something like that. Then what you do is you do everything you did with your multiplying fractions. You see if you can factorise or cancel common factors, and then you multiply out. So you get the answer 14 over 15 here. Okay, now why do you do that? Why, when you divide fractions, is that equivalent to multiplying and flipping the second fraction? Well, it's really the definition of division. Division is the exact same as multiplying by the inverse of a number. Okay, so when you divide by something, it's exactly the same as doing multiplying by the inverse. Now, when you take the inverse of a fraction, it just flips it. So that's why it's easier for us to do multiplying with fractions. So when we're dividing two fractions, we change it, we remember that division is actually the same as multiplying by the inverse. So we multiply by the inverse. And an easy way of working out the inverse of a fraction is just to flip the fraction. And that's why we're doing it. Let's have a go at this one. Let's convert it into a division problem first. So we would write that as 5/9 multiplied by 7 over 10. Before we launch into it, anything we could cancel? Well, there's a 5 in both these here. If we cancelled the 5 out, we would get a 1 on top and a 2 on bottom. So now we've got 7 times 1 over 9 times 2, which is simply 7 over 18. Nice and simple. And last one here, convert it to a multiplication, so it'd be 3/7 multiplied by 21 over 9. Can we do any cancelling here? Well, yes we can, because 7 and 21, 7 goes into 7 once and into 21 3 times, and therefore we'd have 3 times 3 over 9, which is simply 1. Okay, so 9 over 9 is simply 1. And you're done. So to summarise it, you split the numerator and denominator into their factors by factorising. You flip the second fraction and convert to a multiplication. You cancel where possible, and then you perform the multiplication. Let's do a few examples here using algebra. Convert this to a multiplication, so it's 2x over 5 multiplied by y over 3. Anything we can cancel? No, so just multiply out, get 2xy over 15, and you're done. Okay, let's have a go at this one here. Change to a multiplication, with 2y squared over 7 multiplied by 3 over y cubed. Anything that we can cancel? Well, there's a y squared on top and a y squared times y on the bottom, or a y cubed, so we'd be left with 1y if we cancel that y squared, and so we'd have 3 over 7y. 2 times 3 would be 6 over 7y. Okay, this one here, let's do some factorising first before we launch into, let's factorise and do the flip at the same time. So this factorises to x plus 3x plus 2, okay, over 10. Change to a times, flip it, so 15 over, and we would have a 2x plus 2. Now, let's see where we get to here. We've got an x plus 2 on top and on bottom, so they cancel. And have we got anything common to both? Well, yeah, a 5 goes into 10 and 15. It will go in 2 times here and 3 times here. And so we would get 3 multiplied by x plus 3, all divided by 2 times 2, which is 4. So 3x plus 3 over 4 would be our final answer. Okay, your turn now. Have a go at these 8 questions. Pause the video, work through them, and in 10 seconds I'll give you the answers to these. Okay, let's work through these then. I'll do them in 2 separate sections, the top part and the bottom part. Working through these answers, I'm going to be very quick here. It would simply be 3 over x squared multiplied by 3x over 2. That x cancels with one of those x's, and you would simply get 9 over 2x. Okay, part B, you would get x squared over 2 multiplied by x over 2, and you would therefore have x cubed over 4. Part C, here we would have x over x plus 1, okay, and we would end up multiplying that by x plus 1, all divided by 2. That x plus 1 and that x plus 1 cancel, and we get x squared over 2. This one here, part D, we would get x plus 2 over x subtract 1, and we would get that multiplying by x squared over 2x plus 2. That x plus 2 would cancel with that, and we would end up with x squared over 2x minus 1, or subtract 1. And that would be the first 4 done. Moving on to the second 4, slightly harder here, not too much. Let's factorise as we're doing it as well. So this would be x plus 2 over 2x plus 3. I can't factorise this. Multiplied by this here. If I factorise that, I could factorise out of 4 and I would get 2x plus 3. If I factorise this, I could factorise out of 2 and I would get x plus 2. That goes with that, that goes with that, and 4 over 2 is simply 2. This one here, let's factorise and do at the same time. It would be x over 5 minus 2x multiplied by 2x minus 5 all over 3x. That x goes with that x. Now you should remember from video 1, this here, 5 minus 2x, is the negative of 2x minus 5. So this divided by this is actually just minus 1. And minus 1 over 3 is just minus a third. Okay? C, let's factorise as we go. We get 1 over x plus 2, x plus 4, and we'd multiply that by this here factorised, which would be x plus 4, x plus 4, all over 1. One of the x plus 4's cancels on top and bottom, so we get x plus 4 over x plus 2. And last one here, so we would have a 5x subtract 1. On the bottom, we're trying to factorise this, so let's see if we can. What multiplies up to 3 with 3 and 1? So we would want plus 3 and minus 1 there, like so. Change that to a times, and on top you would have 2x, x. You want to multiply up to 6, so it should be 3 and 2, so this would be a 2, this would be a 3, so that would be a 2, that would be a 3, and that would be all over 1. The 2x plus 3 cancel with that 2x plus 3, and then you'd just be left with 5x minus 1, x plus 2, all over x minus 1. And you're done. And that is dividing fractions. So we've done multiplying and dividing now. Just to finish, we should do adding and subtracting fractions. Now, before we look at the green thing here, adding and subtracting fractions, just think of it as units, adding units of the same thing. You can't add directly euros and pounds. You have to convert them both to the same currency or unit before you can add them. So you always have to make sure the denominator is the same. That's the unit, and it helps us how we read this out. 1/7 plus 3/7, well, how many sevenths have we got? 4/7. And we're done. 2/3 minus 1/6. Well, it's like pounds and euros there. We can't subtract these until we have the same units. Now, to make the same units, you work out what the lowest common multiple of the two denominators are. the lowest common multiple of 3 and 6 is 6. So you convert the first one to something out of sixths. So how would you do that? What equivalent fraction over a 6 is 2/3? Well, you'd have to multiply top and bottom by 2. So it would be 4/6 minus 1/6, and you get the answer 3/6, which you then should cancel down to a half. Here, well, what's the lowest common multiple of 7 and 5? Or 35. So you make them both out of 35. So this, to make 7 and 35, you multiply by 5. So you multiply that by 5. To make 5, 35, you multiply by 7. So you would get the answer 31 over 35 for that. And last thing here, the lowest common multiple of 4 and 6. Well, they both go into 24, but is there anything smaller? 12 is, and 4 goes into 12 3 times, so you multiply by 3, and 6 goes into 12 2 times, so you multiply by 2, and you get 1/12. Okay, so to do it with algebraic fractions, you split the numerator and denominator into their factors by factorising. You factorise first, decide what the lowest common multiple is, cross multiply out to make the lowest common multiple the common denominator, expand, simplify, refactorise if possible at the end. So let's have a go. 2 over x plus 7 over x. 2x plus 7x must be 9x, if that's the way you say it. They've got the same unit on the bottom, so you can add them straight away. Now, these do not have the same unit or denominator. So, what is the lowest common multiple of 2y and y? Well, 2y is. So make both fractions have 2y. To make that a 2y, you have to multiply by 2. So you must do the same to the top, so it's the same value or fraction. So it would be 4 over 2y minus 1 over 2y, which is simply 3 over 2y. Here, how could we deal with this? Well, what's 1 as a fraction? Well, it's 1 over 1, right? Now, what could we make the denominator so they both have the same one? Well, we should make them x, shouldn't we? So, how would we make the bottom, this one, x? We'd have to multiply top and bottom by x. And then we could combine them and we'd have 1 subtract x all over x. What about here? Okay, we ask ourselves, what's the lowest common multiple of x minus 2 and x plus 1? Well, their product is, so in this case, the denominator you choose is x minus 2, x plus 1 for both of them. And we have a minus here, so x minus 2, x plus 1. Okay, now, what did you have to multiply this by to get this denominator? Well, x plus 1. So you had better multiply the top by x plus 1. And what about this? To get the x minus 2 here, you have to multiply that by x minus 2. Now, careful here, I'm just going to extend the page. This, when we combine these, we would have x plus 1 on the top, subtract everything from here. We're going to subtract everything. So I'm going to keep it in brackets so we don't make a mistake. Okay, now x subtract x is nothing. 1 subtract 2 is actually -1. So this threw up a bit of a surprise result there. Be very careful here. Don't just, if you forgot your brackets here, you might be tempted to just say x take away x is nothing and 1 plus 2 is 3. It's not that. This subtract means subtract everything from this side, so be very careful there. Last two examples, slightly harder. Let's have a go at these. Before we launch into it, always try and factorise. It could make your life a whole lot easier. So write that as 3 over, that factorised would be x plus 1, x plus 2. subtract 2 over that factorised, which would be x plus 2, x plus 2. Now, what is the lowest common multiple of x plus 1, x plus 2, and x plus 2, x plus 2? Well, they've both already got an x plus 2 in it. The lowest common multiple would have one extra x plus 2 from this side and an x plus 1 from that side. Okay, so it must have two of these and one of those. So let's see if we can, the lowest common multiple therefore would be an x plus 1. It must have an x plus 1 because that had one. It must have that x plus 2 there, and it must have the extra x plus 2 from here. Okay, and we'd write x plus 1, x plus 2, x plus 2. Okay, what did you have to multiply this by to get that? Well, x plus 2, so we'd have 3x plus 2. What did you have to multiply this to get the x plus 1 on the bottom? X plus 1. Okay, and now we're nearly ready to sort this out. Let's just have I'm just going to move this up here so we've got a bit more space. Now be very careful here when you're multiplying out. Let's multiply this out. This is 3x plus 6. Subtract everything from here. Subtract 2x plus 2. Okay, and it's all over now. I'm just going to write that as x plus 1, x plus 2 squared, rather than writing the x plus 2 out twice. And now we can finish off by just, I don't have enough room to write it down, 3x take away 2x is x, and 6 take away 2 is 4. And we're done. Okay, and last one, example 5, as I said, always start off by factorising. This would be x plus 2. Okay, and this here would be x minus 4, x plus 3. This here would be, you've got your x plus 1 on top, and on the bottom you would have x plus 3, x plus 2. Okay, you need a lowest common multiple for the bottom. Well, they've both got an x plus 3 in it, so x plus 3 has to be in there. And this one's got an x minus 4 and that one's got an x plus 2. So the lowest common multiple would be x minus 4, x plus 3, x plus 2. Now, what did you have to do to this denominator to get an extra x plus 2? You had to multiply by x plus 2, so you'd have x plus 2 squared. What did you have to do to this denominator to get the extra x minus 4? You had to multiply by x minus 4. Okay, and we're going to attempt at combining these, see if we can. Let's expand as we go. The x plus 2 squared would be x squared plus 4x plus 4. Remember, subtract everything on the top. This expands to x squared minus 3x minus 4. And it would all be over the common denominator, which we've got now, x minus 4, x plus 3, x plus 2. Right, now let's try and combine. X squared minus x squared, they cancel. 4x subtract negative 3x is 7x, and 4 subtract negative 4 is 8. So we end up getting the following. And there's no way of cancelling that down any further. And we're done. They're all the type of examples you need in order to be able to add and subtract algebraic fractions. Okay, last thing to do now, pause the video, have a go at a few yourself and check you get the right answers. In 10 seconds I'll go through. Here we go. Okay, going through these, this would simply be, I'm not going to talk too much, I'm just going to show you how I wrote it. Okay, now I'll just start talking here. The lowest common multiple in x plus 4 squared and x plus 4 must be x plus 4 squared. So this denominator stays as it is. This one, I have to multiply by another x plus 4 as I must do to the top. Okay, and then combining it, 3x take away x is 2x, and then you'd have subtract 4 all over x plus 4 squared. And last one, I'm just going to factorise here. I should write in more lines, but if I factorise that, I'd get x plus 3, x plus 3. If I factorise that, I'd get x plus 3, x plus 1. So on a common denominator, I'm jumping a step here. The overall common denominator must be x plus 3. It must have two x plus 3's in it and x plus 1, so it must be x plus 3, x plus 3, x plus 1. This here already had the two x plus 3's, but it needed the extra x plus 1, so I must have had a 2 multiplied by x plus 1 to be up there, and this one needed another x plus 3, so it would be subtract 3x plus 3, and if you work that out on top, 2x plus 2, this I'm just going to jump steps here because I'm running out of space. This would be 2x plus 2, this would be subtract 3x plus 9. So when you do that subtraction, you should end up getting minus x minus 7 all over this here, x plus 3, which I'm going to write as x plus 3 squared, and x plus 1. And we're done. We've practiced everything you need on adding and subtracting algebraic fractions. Okay, just to finish with then, you should read through chapter 1, pages 4 to 7 of your core 3 book and work through their examples. Do exercise 1b and 1c. 1b is on page 5 and 6, do all parts, and do 1c, all parts. And then tune in to the next tutorial, tutorial 3, on mixed and improper algebraic fractions. Thank you for watching. I hope you found the following useful in your study.